Have you ever stopped to think about how your office network, with, hundreds of devices all trying to talk at the same time, doesn't just completely crash and burn? Well, the answer is this kind of hidden hero, the network switch, and these amazing virtual worlds it can create. So let's dive in and break down how this tech actually keeps all our data flowing smoothly.
Okay, so to really get why switches are such a big deal, we've got to take a little trip back in time. Back to the early days of local area networks, LANs. And let me tell you, back then, things were, well, they were noisy. Connecting a bunch of devices was basically like shoving them all into one giant room where everybody had to shout over each other just to be heard.
And that really brings us to the central question here, right? When you hit send on an email, how does that little packet of data find its way through this sea of other devices to get to the one place it's supposed to go? How does the whole network avoid just becoming a permanent digital traffic jam?
So there's actually a technical name for this chaos. It's called a collision domain. And the best way to think about it is imagine a mail carrier standing in a massive crowded lobby, and for every single letter, they just shout out the recipient's name. Everybody has to stop what they're doing to listen. And what happens if two carriers shout at the same time? Yep, the messages get all mixed up and garbled. That right there is a collision domain, and it's a really, really bad way to get a message across. So, how did we fix this absolute mess? Well, we got smarter. We basically invented a traffic cop for our data. A mailroom concierge, if you will, a device that could finally bring some order to all that chaos. And that is where the hero of our story comes in, the network switch. And this really shows you the night and day difference. The old way with a hub was like using a megaphone. One message just gets blasted out to everyone whether they need to hear it or not. The smart way with a switch is more like a targeted whisper. The switch actually looks at where the data is supposed to go and sends it only to that one specific port. It breaks that one giant noisy room into a bunch of small, private conversations. Yeah, it might not look like much, just a box with a bunch of ports, but this little thing was the breakthrough. By giving every single connection its own private lane, the switch makes sure your data has a clear, open road to its destination. No more digital gridlock. It's a game changer. All right, so how does it actually pull off this magic trick? How does a switch just know where every single device on the network lives? Well, it's not magic, but it is a really clever three-step process. You'll find that pretty much every Layer 2 switch operates on these three core functions. It learns, it decides, and it protects. So let's break down each of these, we'll call them superpowers, one by one. Okay, first step, address learning. Now, every single device on a network, I'm talking your laptop, your phone, everything, has a unique serial number that's hard-coded right into it. It's called a MAC address. The first time one of those devices sends out any data, the switch sees it and basically goes, aha, so that's who you are, and I see you're plugged into my port number 3. It's exactly like that mailroom concierge seeing you for the very first time and jotting down which mailbox belongs to you. So when you first plug in a switch and power it on, its brain is totally empty. This table right here, its MAC address table, is a blank slate. It knows absolutely nothing. It has zero idea which devices are connected to which ports. Think of it like that concierge's very first day on the job. The directory is completely blank. But the second devices start talking, the switch is all ears. It just listens and learns. A computer on port E0/0 sends a packet and boom, the switch adds its MAC address to the table. Then another device over on port E0/1 sends something and it gets added too. The switch is actively building its internal directory, mapping every single unique device to a physical port. And here is where the magic really happens. This is the payoff. Once that table starts to fill up, the switch can make smart, intelligent decisions. So when a packet comes in and it's addressed to device 000B, the switch just glances at its table, sees it's on port E0/1, and sends the packet only to that port. Every other port gets filtered out. The mail goes directly to the right mailbox and nobody else is bothered. Simple as that. And this image just illustrates the result perfectly. Instead of that broadcast chaos you get with a hub, you get these clean, direct, point-to-point connections. It's so much faster, way more efficient, and a whole lot more secure. This right here, this is the secret sauce. This is what makes Layer 2 switching so incredibly powerful. All right, on to the third function, and honestly, this one might be the most critical of all, loop avoidance. Now, in network design, having backup paths, redundancy, is usually a very good thing for reliability. But for a switch, an accidental loop in the wiring, if you don't have protection, can be absolutely catastrophic.
So check this out. When a broadcast message, one that's meant for everybody, gets caught in a physical loop, it gets duplicated and forwarded endlessly. This creates what's called a broadcast storm. And this storm can eat up all your bandwidth and literally crash the entire network in just a matter of seconds. It's bad news. To stop this from happening, switches use this really clever system called Spanning Tree Protocol, or STP, which intelligently finds and blocks those loops before they can cause a total meltdown.
Okay, so once we've got this whole physical switching thing down, we can take it to a whole other level. We can start creating virtual networks using the exact same physical hardware. And this is the magic of VLANs. So a VLAN, that stands for virtual LAN, is basically a way to take a single, say, 48-port switch and tell it, hey, I want ports 1 through 10 to be their own little sales network, and then I want ports 11 through 20 to be the engineering network. Now, even though they're all plugged into the same physical box, devices on the sales VLAN have no way of talking to devices on the engineering VLAN, at least not without going through a router first. It's just like creating totally separate secure mail systems for different companies that all happen to be in the same office building. And the benefits here are just huge. First, you get way better security, because you can keep, say, the finance department's data completely walled off from the rest of the company. You also get better performance, because a broadcast from the sales team doesn't slow down the engineering network. And on top of all that, you get this incredible flexibility. You can group people by their job function, not just by where their desk is physically located. And the best part, you can do all of this without buying a single new piece of hardware. So let's bring it all home. Why does any of this matter? Because these concepts, which might seem a little abstract, aren't just nerdy technical details. They are, quite literally, the foundation of our modern digital world. This quote from the source material really just says it all perfectly. The goal isn't just to plug things in and connect them, it's to build a network that's clean, meaning it's efficient and organized, cost-effective, so you're using your hardware to its absolute full potential, and resilient, meaning it can handle errors and just... So if there's one big takeaway from all this, it's this. The next time you hop on the Wi-Fi or stream a video, just take a second to remember the silent, intelligent work being done in the background by switches and VLANs. They really are the invisible backbone that brings order to all that chaos, making the seamless digital lives we all live possible. And that leaves us with one final thought to chew on. We figured out how to create these virtual networks inside a single building. But what happens now as our data moves into these massive, globally distributed cloud data centers? How do we stretch these same ideas across the planet? What does a virtual network even look like when it has to span entire continents? Well, that is the next great frontier in taming network chaos.